This session will present a desktop overview. The Keratron Scout desktop consists of many components. First, the menu bar. The menu bar contains options for various operations. These operations will be covered in individual sessions. To access any menu bar item, point to the menu bar item, and then you can select any item under the menu item by clicking that item. The next section is the icon menu bar. The icon menu bar is used most often than any other portion of the software. Here you will be able to call up map types, perform all operations. If you point at any item on the icon bar, it will pull up a tooltip telling you what that item is. In this case, the first icon is Show or Hide the Database Explorer. Calibration, acquire images, process all images, repeatability check, save test, print test from templates, and print screen, which will print to the entire screen. Take pictures or movies if a digital camera is connected to the system that has a Windows-based operating system. Arrange windows. If you have several maps on the screen and they're remove one, click this button. It'll rearrange the windows to maximize the amount of display space. Clear all windows will clear the windows of all maps on the desktop. Help section contains all of the help files for the software, which are very, very feature-rich. We suggest that you consult these on a continual basis. In this section, we have map display types. This map would, if you had a map up on the screen or had something selected, and had a file box selected in the Database Explorer, you can click Photo Process Map, and it would process that. It would process that map into a rings image. Curvature map, which is default, axial map if you need one, and a spherical offset with a vertex. Next is the difference mapping. You would do post-procedure minus pre-procedure will give you the difference in shape. A profile and 3D panel is available when you're doing height maps, or if you want to look at a profile of a curvature or any other map style, this will create a profile box for you. Move axis allows you to map from another point on the cornea. Contact Lens Editor is the internal contact lens program that the Scout has for creating conventional contact lenses. Corneal wavefront map will produce a corneal wavefront map of the selected image. Options would bring up the options menu, and you can make changes to display types and just about any other information you wish right here. We will cover these in another session. And the wave icon is right here. If you have an extrapolated image up, or you have an extrapolated image already saved, you can click wave, and if you select that image, you can click wave, and it will start the wave program. This section is the scale references. The system defaults to the absolute scale. So if you have gone to an adjustable scale or a normalized scale, you can always go back to the absolute, which is the scale of reference for most tests. The adjustable scale is used primarily by researchers or study groups looking for specific shape types. The next toolbar is the Database Explorer toolbar. This will allow you to sort in chronologic order, alphabetical order, by group, by operator. Normally it's in alphabetical order. A change modify patient data button is here. If you have some patients selected and you wish to change their data, you may do so here. If you have a test selected, you can click this box and change or modify test data, adding different refraction data or notes, comments, things of that nature. A search engine is available. You can look for items based on these subjects. And the pre-selection workbench is available here. If you have a file box selected, you can open the pre-selection workbench and take individual items from that one file box or from many file boxes and call up different kinds of test modes. This will be covered in detail in another session. The test manager, call it up and you can add items to it, and you can either export them, print them, email them, or export them as Microsoft Access files. We will cover this in another session. The Database Explorer itself consists of the database containing all patient data. In the alphabetical order, file folders for patients who have been entered with initials such as A will be listed under A. Their names will be listed. Then underneath that would be a file box containing the data for that specific test. As you store images and subsequent tests for this patient, you would have additional file boxes in line. The display screen itself, this is a display for one map, contains the scale at the top. In the top you see it's in diopters from 9 to 100 diopters, 100.5 rather, and in a corresponding radius of curvature. In the map display, we have several items. This is the normal daily routine map display as set up. Curvature is the type of map it is. The name of the title bar of the map contains information relevant to that map. This is astigmatism, test number 1, noted here, and image number 1, noted here, and the patient name and the date of the test. The map display shows the meridian clock dial, 0 to 360, 3, 5, and 7 millimeter circles as points of reference. The odd-shaped circle is the pupil, as determined by the Scout's detection system. You may click on any area of also the right and left indicators are in the lower right-hand corner of the map, OD and OS. You can click on any point on the map and your pointer will go to that point. If we look in the central portion, we see that the white cross, which is vertex of the cornea being the furthest protrusion of the cornea, plane tangent to the line of sight. The small black X is the center of the pupil. In most cases, they're very, very close to each other. In some cases, though, they may be widely offset. That information is reported elsewhere. We'll show you that in a moment. Pointer values. At any point that you select, pointer values will change. At this point, pointer values are 48.81 diopters in power. That corresponding radius in millimeters is 6.91. Distance from vertex is 1.41 millimeters. Meridian, 49.61. If we follow this line, we'll see we're right along in this area, 49.61. And height, which will always be a negative number, is 142.3 microns. So what we've done is gone out 1.41 millimeters and gone down and reported the height that the cornea is from that plane. Now, you may also press the left mouse button and drag and get continuous readout of values. And when you let go, your pointer will go to that point. It always starts out and you call a map up at that vertex. And you remember that the power that you see here is for the one single point that you're pointing at. It's not an aggregate of anything. It's just the single point, that point. Okay? SimK, simulated keratometry. This is exactly what it is. It is simulated. Keratometry looks at, standard keratometry, optical keratometry looks at 4 rather fluid large points on a 3mm circle. The SimK here looks at 4 different pixels on that circle and comes up with a steep and flat meridian and a difference. On regular corneas, not irregularly shaped, the simulated keratometry will be pretty close to what you would get with optical keratometry. But if there are any anomalies at all within the 3mm section of the cornea, the simulated keratometry may be different from what you would read with an analog optical topographer. Please note that the Wave contact lens software has no relationship with keratometry whatsoever. It does not use these values. They're not used. They're used as points of reference for you. Best fit Maloney, best fit sphere, best fit cylinder, and a best fit topographical irregularity index. This information comes from analysis of all data within a 4mm circle. All of the data is considered. And a best fit sphere, considering all the bumps and hills and valleys, it would be 4609 for this eye, and a best fit cylinder would be 3.7, corresponding very closely to the difference noted here. And the best fit topographical irregularity index is equal to 0.19. Normal has been determined to be somewhere around 0.2. This is above normal, one would say. And if we look at this cornea, we would say, well, it looks rather irregular, but in reality it is not. It is astigmatism, but it is quite regular astigmatism, and the shape is highly regular. Although astigmatism optically is not good, physically and shape-wise, the shape is very, very regular. The higher the number, the more irregular the cornea. For instance, an offset cone would read on the order of 4 point some numeral. E values over an axis of 8mm. That's from about here to here. That would be eccentricity on the steep and flat meridians. The higher the number, the more eccentric the eye, or the further it is along the more steeper or more prolate section of an ellipse. The lower the number, the lower the rate of change over this axis, even into negatives, which you would see with LASIK and post-ortho-K items. That would be more oblate on the flatter side of an ellipse. Pupil information is given. Pupil diameter, in this case, is 3.10 millimeters. It's offset at 0.32 millimeters at 195. Look at 195. Basically, that line lines up with 195, and it's offset 0.32 millimeters, a little over a quarter of a millimeter. The one more section for the Database Explorer is the Patient Information Report. This information is not where you enter it. This area is not where you enter information. This area is a report of information that has already been entered. This patient we've selected has his name and all information here. And if we click on Test, it has not been grouped. An operator who has nothing's been chosen. Because when we choose a file box, this information will be filled in. The operator, the disk type, when everything was done. And in the OD and OS section would be any diagnosis notes and the manifest refraction information if it had been entered. In this case, in this patient, it has not been entered. This concludes the desktop overview session.